Good evening. I'm LaChance, co-founder and CEO of ZenFi Networks. Before I get started, I want to thank the Pacific Telecommunications Council for the opportunity to participate as a speaker at today's event. Like most of you, I'm disappointed that we can't all meet in person in Hawaii for this year's conference. But like all of you, we're adapting to the new norm of digital conferencing. So I'm recording this video from my home office in Greenwich, Connecticut, where the temperature is a crisp 29 degrees Fahrenheit. For today's talk, I'm going to focus on 5G and shared infrastructure and draw on the analogies between the mature tower industry, where mobile network operators sharing of vertical infrastructure is commonplace, and describe how the evolving 5G infrastructure build now underway can't happen without adopting the same approach. As the world of communications continues to evolve, shared infrastructure has become the most promising solution for reducing cost and easing the deployment process across the board. In both physical and virtual infrastructure environments, we see a demand for a new network architecture that is purpose-built to deliver the 5G promise. This session will explore the challenges and opportunities that are driving the shared infrastructure model, the important benefits that shared infrastructure offers in support of densification, and the ways in which shared infrastructure is being achieved in today's landscape. So today, I'm going to talk about what we and some of the industry call the horizontal tower. But before we jump into that, I think a brief overview of my company, ZenFi Networks, will be useful for context. ZenFi is a New York-based regional communications infrastructure provider of fiber optic networks, network edge co-location, and wireless siting solutions for the mobile operators. ZenFi's infrastructure is shared across multiple customers, enabling the operators to deploy network assets more rapidly in more places at a lower overall cost of ownership. We currently own and operate more than 1,300 route miles of fiber optic network, interconnecting 50 co-location facilities, supporting approximately 3,000 wireless sites with almost 6,000 under contract, including macro towers, small cells, and end-user buildings. Almost 20 years ago, I was fortunate enough to find myself as CEO of a regional fiber provider, LaChance Metro Connect, based in New York City. LaChance was a dark fiber provider focused on providing fiber circuits to the usual suspects: large banks, media companies, schools, and hospitals, interconnecting enterprise buildings to enterprise buildings to data centers, and data centers to data centers. In hindsight, LaChance was a legacy backhaul dark fiber provider that solved for what I now call a sparse networking problem, with high-capacity fiber optic cables interconnecting sites few and far between. These backhaul networks are just as important today as they were 10 or 20 years ago. However, we have a new problem to solve for as the wireless industry evolves from 4G to 5G. In 2014, when we launched ZenFi Networks and started building fiber optic networks around New York City, our peers in the industry thought we were just building another fiber business like LaChance. However, as we carefully considered new business ideas in the telecommunications asset space, we developed a very different plan to build an underlying wireless infrastructure business that not only provided fiber optic circuits, but solved for the complete end-to-end infrastructure needs of the mobile operators. At the time we were starting up, we were seeking an opportunity to build a business that would support what we believed would be one of the greatest growth areas in telecommunications infrastructure solutions, supporting the mobile operators as they densified their 4G networks while providing a path forward to the evolving ultra-dense 5G networks. When we began using the term horizontal tower to describe what business ZenFi was in a few years ago, it was not just to be opportunistic and partake in the stratospheric valuations afforded to the tower companies. We were building a collection of hard network infrastructure assets similar to tower owners that high-quality counterparties, like the mobile operators, willing to sign long-term contracts with escalators to use it for 10, 15, or 20 years or longer. Setting aside the massive asset class growth and financial opportunities, I'll describe why our product offerings and solutions are more like a tower company than a traditional fiber provider, even though providing fiber networks is a core fundamental element of our business. Our thinking at the time was that a convergence theme in the telecom industry needed to play out between wireless network, wireline network, and data center infrastructure providers. In 2021, that convergence is evident to everyone. But 6 or 7 years ago, I was always perplexed that the so-called fiber and data center companies weren't showing up at the wireless conferences. And conversely, the wireless crowd wasn't showing up at the fiber and data center conferences. Today, the lines have converged. And it's clear that to be competitive in the communications infrastructure space and provide solutions to the mobile operators, you must provide end-to-end infrastructure that includes fiber optic networks, network edge co-location, and wireless siting solutions for small cells and macro sites. Please note that I'm using the term small cell loosely to capture the whole class of low-powered radio sites being placed close to the user, including small cells, mini macros, remote radio heads, DAS remotes, and Wi-Fi access points. As we all know, 5G promises high bandwidth delivered at low latency with quality of service and class of service controls that will enable applications we can't even imagine today. To deliver on the 5G promise, operators need to add capacity to the network, and there are 3 primary ways of doing this: buying more spectrum, CBRS, C-band, 28 gig, 39 gig, check that box, making that spectrum more efficient. 5G OFDM modulation technique checks that box, and densifying or adding more small cell sites to increase the amount of available capacity to the network. With hundreds of thousands of new small cell sites planned throughout the US, and some estimates reaching as high as 800,000 sites in the next 5 years, clearly this massive undertaking is still a work in progress. While the operators and equipment manufacturers tackle the spectrum and modulation problems, shared communications infrastructure providers like ZenFi, Extenet, and Crown Castle are working on and building out the physical infrastructure required to support the mobile operator needs. So what do we mean when we talk about the horizontal tower? Well, we often use the term in 2 ways. In one use, we use horizontal tower as a proxy for the entire mobile communications infrastructure ecosystem, where the network of all mobile infrastructure assets is the tower of the past. In a more literal interpretation, the horizontal tower is the corollary to the vertical macro tower, where baseband units on the ground are connected to the remote radio heads vertically, a couple of 100 feet in the air on a rack. Just pause for a second and visualize the same elements: baseband units on the ground in a neighborhood co-location facility, connected via fiber optic cables running throughout the streets to small cells mounting on lampposts, street furniture, building facades, tunnels, or even on every floor of every building. Again, try to visualize the same technology deployed vertically at a macro tower site, except laid out horizontally throughout a neighborhood, a city, or a suburb. To further analogize the distributed RAN macro tower model, those network co-location facilities, like tower sites, are connected back to the carrier's mobile switching centers via high-capacity fiber optic backhaul networks. One of the ways network operators are coping with the reality and preparing for the future of 5G is to transform the radio access network by centralizing its high-cost, complex elements in the cloud and distributing low-cost elements any and everywhere its users are using small cells. This cloudification of the RAM, commonly referred to as C-RAN, will ultimately increase the performance and enhance flexibility, enhance the services, and reduce overall CapEx and OpEx cost. To adopt C-RAN technologies, the mobile operators require a completely new underlying transport and co-location infrastructure. So what can C-RAN technologies do in a 5G world? To understand C-RAN architecture, let's first review the typical distributed RAN architecture. In a distributed RAN, the costly base station components and routers are located at each cell site. In this case, the baseband units and remote radio heads are interconnected via protocol like CPRI or others that run over front haul fiber circuits. Wireless signals are processed by the remote radio heads, and the signal is passed to the baseband unit to process calls and forwards traffic to the mobile core via Ethernet backhaul. In contrast, in a C-RAN, the same technologies are used, except the baseband units are relocated from the individual cell sites to the neighborhood co-location facilities, which can be up to 20 optical kilometers away from the remote radio head. With the costly baseband units and routers centralized and the remote radio heads distributed, the mobile operators simplify network deployment and scaling while lowering overall costs. To support this technology evolution towards C-RAN and 5G, the underlying physical space, power, and connectivity infrastructure must mirror the higher layer software and hardware architecture. When I visualize the C-RAN infrastructure, looking from the edge inward, each small cell in the neighborhood is connected to the network edge colocation facility by front haul fiber. The network edge colocation site is then connected to the mobile operator core via traditional backhaul technologies. I like to think of this as a network of neighborhood networks, where the network edge colocation is really an edge data center, initially serving mobile baseband processing needs, and then ultimately evolving to a neighborhood compute and caching location that will be leveraged to support localized capacity, low latency applications of the future. Legacy fiber networks supporting the mobile operators were built to solve for a completely different problem, a sparse networking problem. Those fiber networks connecting the macro sites to the mobile core were built with high capacity, redundant backhaul cables, but were only meant to interconnect relatively sparse endpoints throughout the network. The backhaul network is a piece of the puzzle, an important piece, which we will continue to use. But the front haul network is the new parallel network that the infrastructure providers need to build to support densification. Since these backhaul networks are not meant to be fragmented and accessed every couple hundred feet, they can't support the demands of operators to densify their networks. In an ultra-dense urban environment, New York City, for instance, mobile operators plan to place small cells at almost every intersection, as well as mid-blocks across all 5 boroughs. In Manhattan, which has over 3,300 intersections in a very small footprint, those small cells can be as close as 100 to 200 feet apart. So how do we get from the backhaul networks of today to the front haul networks we'll need tomorrow? First, let me reinforce, all fiber networks are not created equal, and the legacy backhaul networks aren't forward compatible. What I mean by that is they can't be retrofitted to become front haul networks. While there is already a lot of fiber deployed in a city like New York, the only way to solve this problem is to build out a new front haul fiber network using new techniques and technologies. The new front haul infrastructure is being built with high capacity specialty cables ranging from 288 fibers to 1,728 fibers or more. But unlike legacy backhaul networks, they are highly accessible and enabling closely spaced laterals interconnecting densely populated small cells to their network edge colocation centers. The only way the 5G promises of high capacity, low latency connectivity, enabling applications we can't even imagine today will happen is if a fiber-based architecture converges where you take fiber, you connect it to macro sites, you connect it to small cells, you connect it to Wi-Fi, and you bring it back to common aggregation centers on front haul fiber links. And then process and aggregate the traffic and send it off to the mobile core on backhaul fiber networks. For that to happen, we as an industry need to build a cohesive, heterogeneous C-RAN infrastructure. This is the very application of convergence, where we've got co-location facilities merging with fiber, merging with macros, and merging with small cells, at the same time being managed by an end-to-end software layer for command and control. To fully leverage 5G technologies is of all 5 pieces of this ecosystem work together. The horizontal tower is really just a proxy for the convergence thematic in the industry today. As we evolve from the late innings of densifying 4G networks to the early innings of building out ultra-dense 5G networks, it's clear that an entirely new infrastructure needs to be built to augment the work that the infrastructure industry has successfully deployed over the past 30 years. So with that, I'm going to wrap things up and leave everyone with the message. We all have a lot to do, and I look forward to working with you and other industry leaders to bring the 5G vision to life, town to town, city to city, and street corner by street corner. Thank you for your time today, and feel free to reach out to me at any time at LaChance@ZenFi.com with your questions or comments. Stay healthy out there, and aloha.